So the title of this course is Concepts of Physical Science. This slideshow is really just an overview of the course material, just the stuff we're going to talk about in the class, just so you get an idea of what the class is about. So we're going to cover 4 basic topics: physics, chemistry, geology, and astronomy. And so physics is the first one. It's kind of the most fundamental science. We do it first because of that, because the other stuff is explained sort of by physics. Chemistry is the next most fundamental, and then geology and astronomy. The science we do in those depends a lot on the physics and the chemistry that we have to learn ahead of time. And so the physics is the most mathematical of those. And so if you struggle with math, that might be the hardest part of the class, but I would encourage you to just hang on, because the later part of the class is more descriptive. I try not to make the physics too mathematical. You might disagree, but I do try. And so I hope you'll, I hope if you struggle with it, you can contact me, but I hope to make it as descriptive as I can and still talk about equations a little bit so we understand the mathematics, a little bit of the mathematics of how these things work. So let me just give you a brief overview of each one. Physics, I'll just give you sort of a general definition of each of the fields and talk about what we're going to talk about in them. So physics is the study of fundamental particles and their interactions. If you looked up physics in a dictionary, that's probably what it would say, something close to that. In this class, we'll study sort of 3 areas, loosely speaking. The first one is kinematics. That's the study of motion. You've heard these terms: position, velocity, and acceleration. And those are related mathematically due to the work really done by Galileo, maybe. And so we can put some mathematics to speed, velocity, and acceleration and predict motion that way. A lot of good sort of mechanical systems that we build are based on that. The next topic we'll have is Newton's laws. Newton's laws really deal with forces. I would argue that you probably know Newton's laws already. We'll talk about them, and we'll see if you do when we get to them. I bet you will have heard of Newton's laws as individuals. And finally, we'll talk a little bit about waves and light. There's obviously a lot more to physics. We don't cover things like thermodynamics and optics, and electricity and magnetism. We do little optics with the waves of light. But these are the sort of the basic topics we need to cover to sort of build a basis for the geology and astronomy that we'll be studying. Okay. Next one is chemistry. It's the study of the properties, composition, and structure of elements and compounds. And so in this part of the course, we'll talk about the atom, the periodic table, and light and its interaction with atoms. And so you know what an atom is, which is sort of the fundamental composition of matter that still retains all the sort of basic properties. And so we'll just talk about the atoms and the periodic table. The periodic table is a list of elements. It's just how many different flavors of atoms we have, right? There's about 100 or so, depending on how you count them. And so we'll talk a little bit about both of those, and then we'll talk about how light interacts with atoms, because that comes up a lot in astronomy. Geology is the study of the Earth. And so in this part of the class, we'll talk about the Earth's layers, how plate tectonics works. There's a guy named 100 years ago, roughly, who lived 100 years ago, named Alfred Wegener, who was the first person to suggest that the continents have been moving. Everyone thought he was crazy, but they do, and we sort of now understand how and why. It took maybe 50 years into the 1970s before we sort of got all that ironed out. And then we'll study rocks and their cycles, how rocks get recycled on the surface of the Earth. And we'll talk a little bit about geologic time and how we know how old things are. The Earth is about 4.5 billion years old, and we have some pretty good evidence for that. And finally, we'll talk about astronomy. And astronomy, loosely speaking, is the study of things beyond Earth. And so We'll first talk a little bit about, people who just looked up and tried to understand what they were seeing when they looked up. The history of astronomy is a human story. All of astronomy is a human story, I suppose. And it began, several thousand years ago, anyway, in ancient, in Asia and in the Middle East. People. There's evidence of studies of astronomy on every continent except Antarctica, I believe. Either 1,000 or several thousand years from millennia ago, I guess I could say. So then we'll talk a little bit about an overview of how the solar system works, and what we see when we look up, and why the planets do what they do. And it looks like I have a typo in there. We'll study large objects of the solar system. The Jovian and terrestrial planets. That's, the Jovian planets are Jupiter, Saturn, Uranus, and Neptune, and the terrestrial planets are Mercury, Venus, Earth, and Mars. And then we'll talk a little bit about small objects in the solar system. Those are asteroids and comets, and maybe dwarf planets, like the club that Pluto got kicked into. And then if we have some time, we'll talk a little bit about stars and maybe galaxies and beyond. And so that's a rough overview of the class. I encourage you to sort of, I'll have some links to textbooks and my notes, and you can browse all of that stuff. I encourage you to look at stuff online. You can Google almost anything in this class and find some interesting links to it, especially on Wikipedia, for example. All right, that's a summary.